Ancient roads in Mesopotamia used mud bricks and bitumen. In the U.S., early roads included Pennsylvania Avenue and the first interstate road in 1811. Asphalt roads started in 1870 in Newark, NJ. The U.S. has 4 million miles of roads, with 31,000 miles added annually. Asphalt is the primary method for road construction today. Be it a sprawling highway or a simple residential driveway, the road building process typically follows a consistent pattern. Here's a breakdown of how roads are constructed. Site preparation, clearing, and excavation. The initial road construction phase involves clearing land, demolishing structures, removing vegetation, and addressing topsoil. Completion can take up to a decade. Preparatory measures and assessments are crucial, especially for challenging terrains like mountains requiring tunnels or erosion control. Drainage, fencing, and other infrastructure may also be needed. Grading and sloping operations terrain. Preparation is vital. Excavation or backfilling might be needed. Proper grading prevents water accumulation and structural problems. Accurate sloping is crucial, especially in temperature-changing regions like Utah, for safety and road durability. Subbases in asphalt road construction. Following the meticulous grading and sloping process, your road construction team will introduce a crucial element known as the subbase. This subbase constitutes the layer that is positioned atop the natural indigenous soil that underlies the road structure. The materials employed for the subbase can encompass a range of options, including recycled concrete, granular fill, manufactured aggregate, crushed concrete, other forms of recycled materials, like crushed bricks. The subbase material is meticulously compacted to facilitate effective drainage and is composed of substances chosen for their ability to withstand expansion and contraction in response to extreme temperature variations. The depth of the subbase layer is determined by the projected load it will bear. Once the subbase is in place, a thorough assessment is conducted to identify any areas of reduced stability. Necessary remedial measures are then applied to rectify these weakened spots before proceeding to the subsequent layer of construction. Binder and surface course application. Moving forward, the construction process involves the introduction of the binder layer. Remarkably, the wisdom of ancient Mesopotamians becomes evident at this stage. They ingeniously utilized bitumen to prevent the displacement of mud bricks, setting a precedent that endures to this day. Bitumen, a sticky natural substance, is crucial in contemporary road construction. When combined with aggregates, it creates durable roads. Historical use of bitumen likely contributed to ancient roads' longevity, and modern bitumen-bound roads are expected to last longer too. The binder layer provides structural strength and withstands high temperatures up to 240 degrees. Fresh asphalt application. Subsequently, an upper stratum of asphalt will be meticulously laid, bestowing the road with its signature sleek and even surface. The amalgamation of bitumen, coupled with minute particles and aggregates, yields a semi-fluid concoction known as asphalt, which boasts exceptional ease of application and subsequent leveling. The intrinsic color of asphalt is an alluring ebony hue, an inherent outcome of its derivation from oil refining processes. Upon incorporation of these particles, the resulting amalgam imparts a visually pleasing and appealing aesthetic to the thoroughfare. Joints and seamless transitions. Conclusively, a road seamlessly interfaces with other thoroughfares, driveways, entrances, and exits leading to parking facilities. These pivotal junctures demand meticulous grading to guarantee the unimpeded flow of drainage while simultaneously facilitating a secure and smooth passage for vehicles. Materials employed in road construction. Emerging technologies are revolutionizing road construction, fostering sustainability and environmental stewardship. Broadly speaking, road construction relies on an assortment of components, including soils and aggregates, asphalt, tar, and concrete, each contributing to the diverse toolkit used in creating modern roadways. Asphalt composition. Asphalt constitutes a fusion of aggregates and a binding agent. These aggregates commonly encompass processed mineral materials such as crushed rock, sand, gravel, slag, or even recycled substances like discarded asphalt, bricks, or concrete. The adhesive element that binds these aggregates into a cohesive whole is predominantly bitumen. Assorted grades of asphalt are available, and the caliber of the phenol asphalt product hinges on the excellence of the aggregates integrated within its formulation. The asphalt manufacturing process. Asphalt is made by mixing 95% aggregate and 5% binder. Binder viscosity is reduced via heating, solvents, or emulsification before combining with aggregates. The mixture is heated to the right temperature and maintained during transport from the plant to the construction site. Concrete composition. Concrete is a composite material composed of water, cement, and aggregates. It's essential to distinguish between concrete and cement, as they are not interchangeable terms. Cement serves as a powdered binding agent, while concrete encompasses the entirety of cement amalgamated with aggregates. The concrete production process. Much like asphalt, concrete is formulated following a precise recipe, typically consisting of 10–15% cement, 60–75% aggregates, and 15–20% water. In contrast to asphalt, a component of air may also be entrained into the mixture, constituting around 5–8% of the overall composition. Before concrete is deemed suitable for vehicular use, it necessitates a curing period due to the gradual hardening of the cement. Curing involves the controlled hydration of the concrete over a defined duration, often facilitated using specialized equipment or protective burlap cloths. With that said, thank you for watching. Don't forget to like and subscribe to our channel.